Good afternoon.
Good afternoon.
How was your weekend?
Good.
It was good.
Yes.
Even mine was good. So it's a beautiful afternoon and welcome to our physics lesson. The topic for today is magnetic effect on magnetic effect of electric current. So that's our topic for today. So this is physics form 2. The topic is magnetic effect on electric current. So today we have 3 learning objectives. The first one is by the end of this lesson we're supposed to be able to define what a magnetic field is. The second objective, by the end of this lesson we're supposed to be able to define current. And the third one is by the end of this lesson we're supposed to understand the Oersted experiment. The Oersted experiment. So, objectives. So those are our 3 objectives. So our first topic, when we started learning physics in Form 2 was magnetism. It was magnetism. We did some methods of uh, inducing magnetism. Do we remember them?
Yes.
We carry our hands, no chorus answers. One method that you remember, how we can induce magnetism to an object. Yes, lovely. Hammering. Ina. Esther. Induction phase. Electric method. That's nice. So today we are going to concentrate on the electrical method. Electrical method. This one is the one that is going to link us to this topic. So on your books, we draw a table. That table, we divide it into 3 columns. The first column is what you know. The second one, what you want to know. And the third column will be what you've learned. This column will fill when we are done with this topic. So for now, I want you to write on the no column what you know about magnetism or electric currents. And here, what you would like to know. I'll give you a minute or 2, then we share that to the class. So what you know about magnetic field, what you know about electric current. Just one, what you know, one, what you want to know. Just write one. It can be as simple as a definition, it can be an illustration, it can be a diagram, it can be an experience, anything that you know. What you want to know, as simple or as complex as it will get. So then you can write anything on magnetism, anything on electric current, because that is what we are going to build on in our lesson today. assuming that most of us are done, so we can share. So, anything, what you know? Yes, Tracy?
I know how to define a magnetic field.
Define it for us.
A magnetic field is a region
Mhm.
where magnetic influence is felt.
Where magnetic force is felt. That's a good try. Thank you, Tracy, for that one. Any other thing? So, Tracy knows what a magnetic field is. Another person to share what you know? Yes, Faith?
A magnet is made up of two poles.
Yes, a magnet is made up of two poles, the north pole and the south pole. North pole. The south pole. The last person, sorry, to share on what they know. Let's have you.
For magnetized material, the dipoles face on one side.
Yes, for magnetized material, the dipoles are aligned. See?
Yes.
Dipoles. The dipoles are aligned. On the column of what we want to know. So if you've not shared, I want people who have not shared what they know to share what they want to know. So what you want to know about the magnetic effect on an electric current. So let's share 2 or 3 people. Camila?
How electric current
How electric current
moves.
Yes, how the electric current moves. How the electric current moves. Let's go Camila. Electric current movement. Another one, we have like 2, like 3. So another person, what you want to know? Yes, Lydia.
The connection between magnetic effects and electric currents.
So the connection between magnetic effect and electric current. Yes, the connection between magnetic effects and electric current. The last one, maybe to share what they would like to know. Somebody to share what they would like to know, what you've not on the board. I'm waiting for a response. Yes, lovely.
How does an electric current, how does a magnetic field affect an electric current?
How does a magnetic field affect the electric current? And that's nice. How a magnetic field affects electric current. So those are very nice trials. Trials or knows and wants to know. So that shows that we are prepared for this topic. Because the want to know column means that we are curious enough to want to know something by the end of this topic. As I said earlier, the learned parts will do it when we are done with this topic. So our first learning objective was to define magnetic effect, and our second one is to define electric current. So this one, we are going to repair. Yes, I think we will repair. So we will pair with your neighbor or deskmate. So you pair with your neighbor. You think first on your own. What is magnetic field? After thinking and getting what a magnetic field is, now you pair with your neighbor. After pairing with your neighbor, you share the whole class. So I want us to define these 2 terms, the magnetic field and the electric current. So that one we'll do in like 5 minutes or so. We'll do in 5 minutes or so. So let's think individually first. What is magnetic? What is magnetic effect and what is electric current? Because this is just a repeat of what we did when we were doing magnetism. I'll give you some 2-3 minutes. You're free to refer from your books. You can find the definitions there or explanations. So when we are hearing, it's like a discussion. Faith and Esther, you're not discussing. You're done discussing. Sharon, are you discussing? Assuming that we are done, most of the groups are done. So we come back to the main class main group. We share now. What is magnetic effect? Any group that is willing to share what is magnetic effect? Diana, you want to share? Okay.
You have said
Yes.
magnetic effect is the magnetic influence on each one.
Magnetic effect is there?
Magnetic influence on a region.
Or magnetic influence on a region. Oh, you're saying it's there? Magnetic. You said magnetic influence on a region. Magnetic influence on a region. Can you define for us region? How is that region, or what is that region? Okay, that, yes, then, no. What is that region? But before we discuss about the region, maybe we can hear some other opinions. Any other group? What did you discuss? What is magnetic effect? Lovely.
We had the same answer, but according to the topic, we can see that we are going to discuss about maybe the relationship between an electric current and a magnetic effect. So you can say our region can be an electric current or a current itself, the influence of a magnet on a current.
On the current. So the current creates the region.
That's it.
Am I getting you right?
Yes.
The current creates the region in this scenario. Somebody defined for us the magnetic field. No. Alisema aje? Nani alidefine? No. Tracy, can you redefine it for us? Magnetic field.
Magnetic field is the
Be audible. No. They have to see. Magnetic.
magnetic field is the influence of magnetism in a region.
Is there?
Influence of magnetism in a region.
In a particular region. So what if tukisema this magnetic influence is around the magnetic field? Will I be right?
Yes.
Because beyond the magnetic field, I'm hoping to remember. Beyond the magnetic field, then there is no magnetic influence. No, it's in a certain region. So I think the region here is the magnetic field. Because even if the electric current is coming to bring an effect, it will have an effect for the magnetic field and the region around it. I think about Kosawa, any questions? Any add-ons? None? Electric current. What is electric current? We were discussing the two serial. Okay, share what is electric current? I'm going to share that. Amani's group is not sharing anything. Amani, what is electric current?
In discuss, since a current is a flow of charges, so we're thinking an electric current is the flow of electric charges.
Flow of electric charges.
Yes.
Esther's group, what did you discuss? Okay, that's a good trial. I'm not dismissing it, that's a good trial. Esther's group, what did you discuss?
We said that the electric current,
Yes.
how the electricity flows from one direction to another.
How the electricity.
Those
Those?
those small
Those small words. The small charges.
yeah,
The way they flow.
yes.
Amani, can you repeat again?
We say we're thinking since currents are the flow of charges, so an electric current is the flow of electric charges.
But you said since current is a flow of charges, so current alone is flow of charges. So electric current is?
Flow of electric charges.
Flow of electric charges. Finance group. Ni mmesema nini? Electric current.
We discussed, we had almost the same thoughts and we said electric current. Is the flow of charges.
Is the flow of charges. Which charges? I'm not understanding. Can you define the charges for us? Which charges? once you are in the same group with Amani, so you said which charges? What are those charges? Give us an example of that charge or a name to that charge. Yvonne? So you are in the same group with Amani, I believe, so you are. Hizo charges ni gani? Nilisema ni gani hizo charges? Or Amani is the spokeswoman. You tell her, she tells us. Or is the spokesgirl? Mlidefine hizo charges? Electric charges. Because when an electric current flows, what moves? What moves when an electric current flows? Like by the time this bulb lights, huh? Something has moved. Nini na moving? Electrons. Electrons in charges. Mbona tunazita charges? Kama mimi si understand charges. Electron charges. Tunaweza define your answer ama we make it better. Labda hiyo bado unakuja kuongezea. Iko sawa hivyo unaona wewe unaona iko sawa?
Because when you talk of electrons, they are negatively charged. So if this the amount of charges, you also electrons is part of which are you saying?
Part of the charges. Okay. I think so. Okay, so we go to the next. We go to our next objective. Our next objective is to understand the Oersted experiment. So the Oersted experiment is a very simple one because tunaongea kuhusu magnetic effect. One thing that can relate to magnetic effects easily inakwanga the compass, ndio? So inakwanga compass. So when we take a compass, let's say for example tuchukue compass, tukiiweka nikiwa na compass tu saizi nishikilie hivi. Ita lie in which direction? Yes? North south, ndio? Kwa nini north south? Topic 1. Kwa nini nikichukua compass saizi ita lie kwa north south direction? Mbona ilai kwa north south direction? Mbona isiende east west? That is a compass. Hatujaleta electric current, hatujaleta anything. Just a compass tukishikilia hivi ina lie kwa north south direction. Kwa nini? Yes, please. Sema na nguvu. Because
of the magnetic field.
What's the magnetic field? The Earth's magnetic field, sindio? Yes. Because of the Earth's magnetic field. So that's why ina lie kwa north-south direction. So this Oersted, I hope I pronounce poor. The Oersted experiment uses a compass, compasses depending on what you want to investigate, and an electric current. So there we vary the current, we vary the direction of the current. Alafu tunaangalia deflection ya compasses. And how can we vary the direction of the current by changing the connection terminals. Nageti inasema. So I want to play a video here to observe. After observing Mtaniambia what you are learning from this video, and it's basically on the poster experiment.
Hey guys, today we'll see some activities which appear simply magical. Here's the first one. A piece of paper on which Here guys, you all know that the needle of the compass always points in the north-south direction. But see what happens when a magnet comes near it. The needle of the compass deflects. The magnetic needle deflects whenever it interacts with another magnetic field, right? On this note, let's do an activity. Here, I take an electric cell and a wire. I connect the two ends of the wire to the two terminals of the cell. So, an electric current flows through the wire. See, the needle of the compass under the wire deflects towards the west. The needle comes back to its original position when we stop the current. Now I turn the cell to change its polarity. This changes the direction of the current through the conductor. See, the needle now deflects in the opposite direction, that is, towards the east. Wondering, where's the other magnetic field that deflects the needle? Is it the wire? Yes, it is. From this experiment, a Dutch scientist named Hans Christian Ørsted concluded that a magnetic field is produced around a current-carrying conductor. This is called the magnetic effect of electric current. This effect of electricity is used in many appliances like electric fans, mixers, etc. We'll see some more interesting activities in the forthcoming videos. So like, share and subscribe. See to learn. And don't forget to click the bell icon. Thanks for watching.
That's it about that video. I hope we've taken important short notes in the video. So let's share. What have you learned from the video? Just 1, 2, 3 people. What have you learned from the video? This video. The compass points on the current. Okay, that's a good one. Another one, what have you learned from the video? She. Lydia, what have you learned from the video? Be a bit audible.
Through the video, come to understand how the currents affect the magnetic field.
How does it affect?
When the current is connected, the compass happens to move in the direction which the current is flowing from.
Thank you for that. Another one? The last one before we do our summary. What have you learned from the video? Yes, Sharon. Oh, nice. Thank you for that. So now let's do the summary of our lesson. So tell me, what have you learned in today's lesson? 1, 2, 3 people. What have you learned from today's lesson? Okay. Be a bit audible about the flow.
The flow, electric current can be affected by
Yeah, the flow for electric current from the magnet. Any other things that you've learned from today's lesson? 2 or 3 people as we wind up. Any other thing you've learned from this lesson? Camila, what have you learned from today's lesson?
I've learned about the methods of magnetization.
Methods of magnetization. That's nice. Any other person? Yes, lovely.
Magnetic field is the region where magnetic influence is felt.
Ah, nice. I think it was a nice interactive lesson. So I want us to evaluate this lesson. I'll give you this sheet of paper, so you just put a dot as to how you feel about this lesson. If it's excellent, good, or bad. This is to help us. If there's need to repeat the lesson, repeat it again. If it's okay, we use this method next time. You get me? Put a dot as it goes around. Let's hurry up. Let's hurry up when we wind up the lesson. So from this sheet, a majority of us feel that the lesson is good or excellent. So meaning that most of us have understood. So one person is feeling that the lesson is bad. So if you are feeling that the lesson is bad, it's not bad as you are feeling bad. The thing is that now maybe you come see me, we see how to help you so that you can understand the lesson a bit. So you can have a good day. Thank you.